Hi everyone and welcome back. Last session we talked about the iPref. We created the file iPref3 and testing the speed test over the proxy that we had from my machine to a server. This session, which is a more practical example based on the previous one, is SSH over proxy. We did iPref over the proxy that we had. This session is about SSH over the proxy, which is a practical example and use cases for hiding our SSH server. So attackers and scanners and brute force, those people that make brute force to our server, aren't able to know that the port that is running or listening is an SSH port. And we can test that. Let me come to the server SSH SSHD. I already changed port of this server to 4 ones. So 4 ones. And reloaded the daemon. So SSH is listening on this port, and this is me connected to the server. So on this terminal, I want to use two commands to detect that this is an SSH server. The first one is nmap. Let me go to nmap, which is the service discovery enabled, and tell me on this port what kind of application is running. It takes a little bit time, like 5 or 10 seconds to show, but most of the time successfully it says or detects that what kind of application we have on the targeted server. Let me clean this up. Waiting a little bit. Okay, this is an open SSH server. So that's it. That's SSH server. So we can realize that even if I change the port to a random one, still people can scan the server and realize that this is an SSH server. So even if I change the port to something else, okay, anything else randomly, again, let me change the port. It doesn't matter really what the port is. For example, I can change it to 2, just like this, and then systemctl restart SSH D, and then running SS on 12. It's listening. It's the same thing, okay? And right now, assuming that I'm going to SSH to my machine, which is port 1112 and then 100. It can go to that machine. But there is another command, which is TCP dump. Let me show you this one, which says that when we have the TCP header, the 32 bytes TCP header, capture based on the filter module on TCP dump, capture the very this 4 bytes when it's equivalent to or it's equal to this ASCII character. So 535348 2D means SSH dash in ASCII. So anyone between me, I mean my machine, let me get out, anyone between my machine and the server, which means ISPs and anyone, I mean any routers, anyone between me and my endpoint machine, a server, can detect that this is an SSH server without knowing the port, which means the random port that we usually people think if they're changing their server port to random, they are safe, but they aren't. If someone wants, they can realize the it's an SSH machine, it's a Linux machine, and this is an SSH server, and the port and the IP, they can detect anything, and this is a test that I'm going to run. So TCP dump, and I tell TCP dump on any interface on this machine, which could be any other machines between me and the server, capture one packet, the very first packet, when it equals to this one, which is SSH dash. Okay, so let me check that. The port doesn't matter, just showing you. It captured that 5348 2D SSH, which is the version that the client sends to the server and tells this is a SSH server that I'm going to connect to, and it's in plain text. It's clear. The handshake is in plain text actually. So coming back, making it 111 again, restart, Listening on one, there's nothing, just the previous one. Getting out, and yeah, it's okay. Now I'm going to run it again. So you can see there's no port. I'm not usually, I mean, people usually TCP time with port 2020. There's doesn't matter really what the port is. Another time, it captures that. So it can, I mean, anyone, and kind of man in the middle attack, anyone in between me and machine, my machine can realize that what kind of, I don't know, IP address I'm SSHing to, the SSH header, and they can realize that this is an SSH server, and then, for example, doing the rest of the attack if they want. So, and we want to hide this. We want to put SSH server that we have behind the proxy server that we have, so it's not that much visible. Let me run the proxy server that we had, the previous version, the previous file we modified, C, which is iProf, just the previous one. So, and then we want to use the nmap we did, and the previous proxy server was 44555. So we want to know that what nmap says about this proxy server, which could be the HTTP, SOCKS, HTTPS, HY2, whatever you name it. It can be any type of proxy with sandbox that you can have. So it says the result, I don't know, PR chat user. It doesn't matter because we can change the port to like 443. Okay, we can change that to any port we like. So nmap doesn't know this is an SSH server, but it's sent because it's a SSH server. We are going to connect to this, and from this to the SSH machine server that we have. So let me copy the iProf file that we had to SSH over proxy JSON. Then opening the file. So in here, get out. And this window, I'm going to say, because we already had the inbound for direct, if you can remember that, please watch the previous video if you aren't sure what you're doing here. So I named this one SSH client, and I changed the port to 11111. Okay, so that was the inbound, and then I go to route, copy this, comma, paste, and I then say that SSH client should go to SSH server. We do not have SSH server outbound, so we go to one of the outbound. The previous one was iProf 3 server. We change this SOCKS, which is the target we want to connect to SSH server, and done. SSH client, we have SSH client. SSH server, we have SSH server on port 11111 for once, and then connecting to the machine. So let me run it. Sandbox run C SSH over. So everything is okay. If I curl to this machine, to this SOCKS, it still works. So I can say, for example, curl 1990 to see what it says. So it says the close port not permitted. So that's the permission that we have for, yeah, that blocked. We previous session we blocked that. Let me try something else. Probably it was 7070. So this is our, because it was connected to the direct one, as long as I can remember, yeah, ABC was direct, so it shows my actual one, so it works. It doesn't matter really. We want to test the SSH one. Let me clean up one more time, and then we say SSH -p 11111, and the host we want to connect is this local machine, which is going to forward this to this machine, to this proxy server, and from this is going to be delivered or forwarded to the SSH server that we have. And notice that my user is SSH, but the server is root. So if I run this, it asks for the password because there is no SSH user here. So, but you notice that the log came here. I say root, going to, let me give it a space and give it a space, going to root over this proxy, and we are here. You can realize that simply and easily we can go through the proxy and then coming to the server and going to a SSH server, and this is possible because we forwarded traffic from this inbound to the outbound, from the outbound to this inbound listening, and then from the inbound to the outbound, which was the direct one. If I show you the iPref one, we created the for example mixed in. Whatever comes to mixed in inbound, it should go to the iPref server, which is the SSH, the same one. It does netting by default and built in, so we do not have to do that. And that's it. This was a demo or practical example of how can we use SSH over a proxy, a more practical one. And we can make it much more invisible, like through the HTTPS, which probably we should be doing it in next session, and making it much more harder to detect and making our SSH server stealth, so it's not visible to the outside people or outside anyone that want to, for example, scan or attack our server for SSH. Thank you for watching. Let's go to next video.